Okay, today we're going to be looking at logical arguments. In other words, we'll be given some information and we want to see if it's a valid argument. Okay, in order to do that, we have to remember our truth tables. Okay, so remember right here, right, P and Q. There's only one case where P and Q is true, right? When is that? Right, P and Q is going to be true only when P is true and Q is true. That's the only case P and Q is true. Okay, P or Q. Well, P or Q is true as long as P is true or Q is true. So the only time P or Q will be false is when they are both false. Okay, if P then Q, remember the only time that's going to be false is when we have a true then false. If true then false. And P if and only if Q, right? If remember the arrow is going in both directions. So if we have a true then false in this direction or a true then false in that direction, it's going to be false. The only time P if and only if Q is true is when they're both the same. And these we have to know very well. The better we know our truth tables, the easier it will be to see if an argument is valid. If this does not make sense, then what I'm going to be talking about today isn't going to make much sense at all either. Alrighty, so in an argument, we're given information. And the information we're given should be true. In real life, it should be true. The information we're given is called the premises. Okay, and so I'm going to be giving you some premises, and they should be true. Okay, whether they are or not in my examples, it doesn't matter. I want to see if you can follow an argument. Okay, I want to see if you can tell if an argument is valid or not. So our premises are always going to be considered true. Now, if the premises, the information we're given, is always true, then the only way we can have a valid argument is if what we're concluding is always true. If I'm trying to prove something, and what I'm trying to prove is not always true, that's not much of an argument. You know, that's not a valid argument. It can only be a valid argument if what I'm trying to prove is always true. So in order to have a valid argument, our conclusion must always be true. Okay, and I wrote this up in the top right-hand corner. The premise is always true. And an argument is valid if the conclusion is always true. Okay, now be careful with these words. I'm not saying that the conclusion is valid. No, the conclusion is always true. I'm not saying that the argument is true. I'm saying the argument is valid. Okay, so we use these words properly. Okay, so premises, always true. Okay, so if I give you a premise, if Sue goes to the movie, then she will eat popcorn. This is what happens. Sue goes to the movie, she's going to eat popcorn. Okay, another premise, Sue goes to the movie. Therefore, see, when you see these three dots like this that look like a triangle, in the shape of a triangle, these three dots, it means therefore. So that's our conclusion. Therefore, let's see, if Sue goes to the movie, she will eat popcorn. Sue goes to the movie. Therefore, Sue is going to eat popcorn. And this would be an example of a valid argument. Okay, writing this symbolically, if we let P be the statement Sue goes to the movie, and Q be the statement Sue eats popcorn, right, then we have, right, if P then Q, right, if P then Q. And in the second statement, Sue goes to the movie, right? That's P. Sue goes to the movie. A simple statement. Therefore, Sue will eat popcorn. Therefore, Q. Okay, another simple statement. Okay, now, if we were just given this symbolically and we wanted to find out if this is a valid argument, right? In order for it to be a valid argument, that conclusion must always be true, right? We can go through this a couple ways. Okay, first we could say, well, let's see, I have a simple statement as my conclusion. Can I make that conclusion false? Right? It's either true or false. Well, let's try. So we let that conclusion be false. And I think of the rest of this like playing a game. We just fill in the rest of the truth values for all of the other letters, the statements that are given. Q is false, right? So Q is false. Now, you see, if Q is false here, P cannot be true, right? Because true then false is false right here, right? True then false is false. That cannot be. We know that this is a true statement. We know this is a true statement. Why? Because our premises are always true. So P has to be false. P has to be false. P has to be false. Well, that can't be. We have a simple statement here. P cannot be false, right? This is a premise and it must be true. So we cannot make that conclusion false. We cannot. Now, when I say that we cannot make the conclusion false, that is while keeping the premise, or the premises, always true. You see? The premises have to always be true, and since the premises are true, we cannot make that conclusion false. So if the conclusion cannot be false, that means the conclusion is always true, so therefore it's a valid argument. So that's one way of looking at this, if we can try to make the conclusion false. Another way of solving this problem is, you see, we know the premises are true, and we have a simple statement right here. No connectives, just P. So we know that P is true. We know that. P has to be true. It's a simple statement. It's a premise all by itself. P has to be true. And now we could start to fill in, right, the rest of the truth values. And so you see, we have to know these tables right here in order to do that. You see, P is true, which means right here, if P then Q, right, Q cannot be false, right? Because if Q is false, if P then Q will be false. Q has to be true. Q has to be true. So since Q has to be true, our conclusion has to be true, therefore it's a valid argument. Yeah, so there's more than one way of looking at these. I mean, you can also go through all the possible cases, true, 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 false, false, true, false, false, and see that as long as the premises are true, is the conclusion always true, right? Because the argument is valid only if the conclusion is always true. All right, so let's look at some more examples. Okay, what I'd like you to do is, I'd like you to write this argument symbolically, and then say whether or not this is a valid argument or invalid. Okay, so pause right now, try this. We'll go through it together, but I just want you to try thinking through it first. Alrighty, the car is red or the car is new, right? So we can say, right, the car is red as P, the car is new as Q. We have P or Q. We know these premises are true, right? We have P or Q. Next, the car is not new, right? The car is new is Q. So the car is not new is not Q. Not Q. Therefore, the car is red, right here, right? That's P. Therefore, the car is red, therefore P. And so now to see if this argument is valid, right? Well, we have this single statement right here. And we ask ourselves, well, what is the truth value of not Q? What is the truth value for not Q? Well, it's a premise, and we know that each of these premises are true. Since this right here is a single statement, we know not Q is true, right? It could be either true or false. But since it's a premise by itself, we know it's true. Well, if not Q is true, then that means that Q must be false, right? Because if Q is false, then not Q is not false. Okay, then here, right, in our first premise, right, in order for P or Q to be true, then P has to be true or Q has to be true. Well, Q is false, so P has to be true. It has to be. Right, because each premise is true, right? We know that premise is true. And so P or Q has to be true. Since P is true, right, then P is our conclusion, therefore P, therefore our conclusion is true. P is always true, therefore we know it's a valid argument. I have lots of these for you to practice. I have another one here. Try this one. Write this symbolically. Write this argument symbolically, and then see if this is a valid argument or invalid. And then we'll go through it together. But press pause and try it. Okay, so the car is red, P, or the car is new, Q. Well, so far it's really the same as what we just did, isn't it? P or Q. The car is new, well, that's Q, right? That's Q. Therefore, the car is not red, therefore not P. I'll write this down a little neater. The car is red or the car is new, P or Q. The car is new, Q. Q. Therefore, the car is not red, therefore not P. Alrighty, well, we have a simple statement right here, right? We know that this statement is true, and we know this statement is true. This right here is a simple statement, just a single statement by itself. Okay, so we know that Q has to be true right here. Q has to be true. And now it's just like filling in a puzzle. We fill in the truth values for all of the other statements. Q is true, right? So we know this statement is true here, right? Well, if Q is true, right, then P could be true or false. True or false, right? Because as long as P is true or Q is true, that will be a true statement. So we have a choice, so let's see what happens. You see, if P is true, then not P is false. If P is false, right, then not P is true. So that means our conclusion could be false or true. Well, remember, an argument is valid if the conclusion's always true. All we need to do is find one case for the conclusion to be false, and it's not a valid argument. So we can make the conclusion false, right? Not P is false when P is true. We can make the conclusion false. Therefore, this argument is not valid. Okay, now can we make the conclusion true? Yeah, we can. But is the conclusion always true? Right here, is the conclusion always true? No. It's only when the conclusion is always true the argument is valid. Okay. Alrighty. Well, if we didn't see that single statement Q right here was true, you see, another way of looking at this is we have this single statement, a simple statement, as our conclusion. And we could ask ourselves, can we make the conclusion false? Can we make this invalid, this argument invalid? Well, let's see. We'll try. Can we make the conclusion false? And now it's like filling in truth values for all the other statements, like playing a game. If not P is false, then P is true, right? Because if P is true, not P is not true. Okay. So right away we see we get into a little bit of trouble. Let's see. We have a choice here. Not really trouble, but you see, Q right here could be true or false, but we have to be careful. Over here, Q has to be true. Q has to be true. So if Q has to be true, look what we've done. Right? This premise is true. This premise is true. I'm sorry, Blackboard just doesn't like me writing on here, or it doesn't make it easy. But we made these premises true, and we made the conclusion false. Therefore, we know it's an invalid argument. Here, I have it a little neater here. Q is true. Q is true. We have our premises, they are true. We made the conclusion false. Therefore, we know it's not a valid argument. Alrighty, try this one. Okay, write this argument symbolically and see if it's a valid argument. And then we'll go through this together in a few minutes. Alrighty, looking at our first premise, if Tom drives the truck, if P, then the shipment will be delivered, then Q. The shipment will not be delivered, that's not Q. Therefore, Tom does not drive the truck, therefore not P. Therefore not P. Yeah, I'll write this a little neater below here. If Tom drives the truck, if P, then the shipment will be delivered, Q. The shipment will not be delivered, not Q. Therefore, Tom does not drive the truck, therefore not P. Okay, well, again, we can look at this two ways, but if you happen to see right here that this second premise is a simple statement, a single statement, it's a simple statement, that means it's always true, then we could say Q is true and then just fill in the rest of our statements, by their truth values. And to me, it's like playing a game. Okay, not Q is true, so therefore Q has to be false. Q is false, not Q is not false. Well, if Q is false, P has to be false, right? Because in a conditional statement, right, whenever you have a true then false, that's going to be false. So P has to be false. It cannot be true. It cannot be. Here. P has to be false, so not P has to be not false, which is true. So our conclusion has to be true, which makes this a valid argument. Alrighty, I still have a few more problems I'd like you to try. Try writing this one symbolically, filling in the truth values, and see if it is a valid argument. We'll go through it together. I just want you to think on your own to develop that confidence in yourself, to make sure that we feel good about doing this. Okay, so press pause, and we'll try it in a few minutes. Alrighty, it is snowing, and I am going skiing, and Q. If I am going skiing, if Q, then I will wear a coat. Now, that's a third statement, then R. Then R. Therefore, if it is snowing, therefore, if P, then I will wear a coat, then R. Okay. So I'll write this a little neater below, right? It is snowing and I am going skiing, P and Q. If I am going skiing, right, if Q, then I will wear a coat, R. Therefore, if it is snowing, if P, then I will wear a coat, R. Now, at first it may seem a little more difficult, but really this one's even easier. We're given more information. We know that these premises are true. Okay. P and Q is true, which means that we know that both P is true and Q is true, because P and Q are both true. Okay, and then we fill in the truth values for the rest of our statements. Right, P is true, Q is true. Now we look at our second premise right here. Right, we know our second premise is also true. So R cannot be false, right? Because when we have a true then false, right, our conditional statement is false. So R has to be true. It has to be. Yeah, I have that a little neater here. R is true. So R is true. And we look at our conclusion. It says, therefore, right, if true, then true. That's a true statement. Our conclusion is always true. Therefore, we know this is a valid argument. Already notice if we didn't see our first premise as both statements having to be true, another way of looking at this, you see, there's only one way that conclusion can be false. So if we try to make that conclusion false, we only have to check one way. You see, the conclusion's always true, except for when we have a true, then false. Right? Otherwise, that conclusion's always true. So let's see, can we make the conclusion false? Just another way of doing this. Okay, so we put in our truth values. P is true, R is false. And to me, it's like playing a game. We fill in the rest of the truth values. Okay, as long as we know our tables above. Right, P is true. Right, R is false. So, eek. Can we make that conclusion false? Well, right away, we notice in the first premise, right, both of these premises are true. They both are. And I know I have this written down next, but notice both of these premises are true. Right here, Q then has to be true, right? Because if P and Q is true, then both P is true and Q is true. But we run into a little bit of trouble, because if Q is true, in the second premise, true then false is false. You see, in the second premise, Q has to be false. Q has to be false. But you see, we run into trouble. Q cannot be false in the first premise. Right? So we cannot make this conclusion false while keeping these premises true. Here, I have it written a little nicer. Right? Q has to be false in the second premise, but we run into trouble in the first premise, right? That makes the first premise false, and that can't be. The premises are always true. You see, Q has to be true in the first premise, but if Q is true, we make the second premise false. You see? So hence, we cannot make the conclusion false. We cannot make it false, not while keeping the premises true. So therefore, we know we have a valid argument, right? If the premise cannot be false, that means the premise is always true. Alrighty, try this one. Write this argument symbolically and see if we have a valid argument. Press pause. We'll go through this in a few minutes. Alrighty, let's see. The dog is a collie, P, or the cat is a Siamese, Q. You have P or Q. Okay, if the cat is Siamese, right, if Q, then, right, if the cat is Siamese, then the bird is a parrot. That's a third statement, then R. If Q, then R. Therefore, if the bird is not a parrot, right, therefore, if not R, then the dog is not a collie, then not P. Not P. Okay, looking at this symbolically, P or Q, right, P or Q, right here, there's three cases that are true, right? It could be true or true, true or false, false, true. And if Q then R, right, a conditional statement is true in three cases also, right? We could have a true then true, or a false then true, or a false then false. And so you can check all of those cases. But notice that conclusion, right, is a conditional statement. That conclusion is always true except for one case. The only time this conclusion is false is if you have a true, then false, right? But the conclusion is always true except for this one case. So the shortest or easiest way of seeing if this is a valid argument, right, is to check if that conclusion can be false. Well, let's see. Can we make that conclusion false? Well, not R is true, so that makes R false, right? And not P is false, so that makes P true. Okay. Now, in the first premise, right, remember both of these premises have to be true, right, true. In the first premise, Q could be either true or false. But in the second premise, right, Q cannot be true. Q has to be false. Q has to be false, right? Because true then false is a false statement. Okay, so Q has to be false. I'll write this a little neater. Right, and look at that. We kept the first premise true. We kept the second premise true. And we made the conclusion false. So if we can make that conclusion false, we know it's not a valid argument. Well, I hope that makes sense. Practice these and let's see how it goes. If you have any questions, of course, you can always ask me.